Welcome to our project, Heat Health Risk Prediction, a systematic approach to reduce adverse impacts on human health. First of all, let me introduce my team members, Nima Sharnaz, Shruti Mukhtar, and myself, Zubaida Rezki. Although many nations in the Mediterranean region have early warning alert systems and heat health knowledge, data in neighboring nations are limited, resulting in a vulnerability gap. Countries such as France possess valuable research in the region. However, according to WMO members' profile site, Lebanon, amongst other region-sharing nations, do not have such systems. Our approach is to bridge this gap by leveraging academic research and heat alerts in the region to provide a holistic and accessible community early warning system region-wide. We created the Heat Health Hub to warn, predict, monitor, and communicate, thereby fulfilling the four core early warning system concepts as defined by IFRC Guidebook on Community Early Warning Systems. The Heat Health Hub aspires to empower communities in data-scarce regions such as Damascus, Syria, and Beirut, Lebanon, with the tools and knowledge they need to proactively address the heat health risks, thereby reducing the adverse impacts of heat waves on human health. Our stakeholders are the general public to create a channel of risk communication, healthcare providers, community organizations, and NGOs to empower their active role in monitoring heat health risks, and WMO supporting their mission to ensure every person on Earth is protected by early warnings.
WMO's Warning System Development Document highlights factors that increase the risk of heat-related issues. Some factors mentioned include physiological factors and age, medical conditions, and gender. So we employed a synthetic data approach to encapsulate these factors to train a heat health risk predicting model. We modeled our dataset off of France's demographics because it shares the same region and, as a G7 country, is rich in data. We utilized rule-based probability distributions informed by reputable sources. The medical conditions integrated into the dataset were strategically chosen based on their frequent occurrence in heat health literature. Utilizing academic articles providing weights of vulnerability factors, excess mortality in the event of heat waves, and various other insights, we meticulously assigned research-derived weights to each factor, calculating a vulnerability score from 0.1 to 1. To delve deeper into the intricacies of the data generation calculations and the details of the risk score algorithm, please visit our GitHub. Finally, we leveraged real-time streaming data through Meteor Alarms API to identify alerts from neighboring countries. We also utilized temperature data from OpenMeteor API. To classify risk scores into low to very high vulnerability groups, we used a quartile-based method, categorizing scores based on their quartile placement. We chose the decision tree model due to its speed, ease of interpretation, and its accuracy, as demonstrated by this confusion matrix. Based on our model results, age had the greatest impact on heat health vulnerability. An interesting discovery was that our model would consistently predict 55-plus people with no medical conditions as high vulnerability as opposed to the Y-true value moderate. As part of our risk communication efforts, we used a risk matrix to inform users visually about their active heat health risk, with the y-axis being the 3-day max temperature and the x-axis predicted vulnerability.
Communicating risk is done at many different levels to reach different segments of the population. We explored one communication option, which was to visualize medical literature related to extreme heat using natural language processing techniques. Our idea was to generate visuals that would encourage people to learn more about the latest medical research on the relationship between extreme heat and human health. We ran a topic modeling algorithm on medical literature available through the PubMed database using SciSpacey and a model pre-trained on biomedical literature. We then visualized the topic using another Python package. You can learn more about the process in the Jupyter notebook linked to this slide. This visualization represents the topics as circles. Hovering over a circle shows word frequency for that topic. Topics closer to each other are more related. We use the topics to tag and filter the articles. This visualization shows how a user can view the latest medical research for their medical condition. This type of visualization might be more suitable for medical NGOs and healthcare professionals and less for the general public. From this project, we discovered two key actionable insights for enhancing community early warning systems in data-scarce regions. One way to close the data gap for constructing a risk framework is by starting with data from neighboring regions and then fine-tuning the model by crowdsourcing data. Secondly, it is essential to communicate heatwave warnings with actionable information regarding heat health risk and preventative measures. Early warnings empower individuals and communities to take proactive steps ahead of the next extreme heat event, and this can lay the foundation for more advanced systems in the future.
Welcome to the Heat Health Hub, a community early warning system for residents of Beirut, Lebanon, and Damascus, Syria. Today we'll explore how this platform empowers individuals like Sarah, a resident of Damascus, to stay informed and prepared for heat waves. Let's start by visiting Sarah's Countries Hub. Here, she can check the weather patterns from the last known heat wave in Damascus. Uh-oh, it looks like a current neighboring country's alert system is going off at a moderate level. Sarah, being proactive, decides to take a risk assessment to understand her vulnerability. Sarah indicates that she is from Damascus, 32 years old, female, and is pregnant. After filling out the form, Sarah can submit it to receive her real-time risk assessment. Here, Sarah discovers in the event of a heat wave, she may be high risk. However, her risk matrix indicates that her risk level currently is low because the high temperature for the next 3 days is 27.5 degrees Celsius. Although her vulnerability is 3 on a scale from 1 to 4, due to the low temperature, she can easily see that she is at a low risk. Here we see a notification to visit the Knowledge Hub for more information on pregnancy, which Sarah indicated she was. To further enhance her understanding of personal risk, Sarah can explore articles on pregnancy in the event of a heat wave, as well as preventative measures to stay safe. The Heat Health Hub is our systematic approach packaged into a community early warning system.
Thank you for listening.